So, my name is Bibekananda Hati. I came from DIT Pune, Defense Institute of Advanced Technology. I am a JRF there, and also I recently completed my MSc in data science there as well. So, during my MSc, I have faced a problem with managing experiments. Like when we are doing any research, we have to try a lot of configurations, like a lot of experiments, hit and trial method, like differing by components like code blocks or even few parameters. And in deep learning, there are like data sets as well. So, my talk will be around that. How can we manage those experiments so that we can use those comparative information to make better decisions while going to the best configuration, starting from a draft one. So I have developed I am developing a tool that is PyLabFlow. Python framework is which is generalized for research experimentation, and for PyTorch for deep learning. It is a PyTorch LabFlow. Actually, I have started with PyTorch LabFlow, and then it becomes generalized. So I just remove Torch from that. So let's talk a little bit about like deep learning. These days, actually, we often see news about AI. Like some model beats some sota. Some model beats some previous one in terms of computation, in terms of data, in terms of inference, for example. So we actually see the best one. We actually miss the hundreds of thousands of failure atoms. The researchers, the developers have gone through the frustrations, like a lot of arguments, discussions, making very little decisions about what to keep, what not to keep in a entire AML architecture, or even the entire workflow of data processing to models prediction, and again after post preparation of the model as well. So deep inside every component, every building blocks of AIML, like in deep learning, there are actually mathematical blocks. They have their own properties, researchers who propose them, who develop them, have no like knows about their behavior, how they gonna behave on standard conditions. But when you stack them like one upon another, like actually we are not stacking them, we are just connecting them, like multiple layers with multiple another layers. Actually may differ by simple linear layers to attention layer, transformer, or embedding CNN. Like there are a lot more technologies in the fundamental blocks. So again we start from a draft, then gradually tweaking every point with a explainable reason behind them, and then go to the best one. So another problem is, even you got the best one, we generally can't explain fully what it does. So to explain what researchers do, like ablation study, and even development time analysis inside against what they have not chosen in any point of their entire workflow. And another thing is, models are evolving, data sets are evolving, like statements are again evolving, like different use cases, different uses as well. So problem is, researchers have to solve those around. to convince people to like trust the AI system or AI model. So there are actually problems. Deep learnings are powerful, beautiful, but dangerous, because we don't actually we actually can not fully explain them how they are predicting good or like bad, both cases. So beyond the hype, we see the final result. We also know in theory, like clean input we are giving to the model, and it actually get the output which is best better. Like during learning we are get excited, but while doing actual research in real data set, in real problem, we get stuck. Like there are a lot of folders we named in like 17 folders, final experiment version 2, changing just last layers, changing few parameters, changing data set, and lot more thing. So theory again, theory, we see like loss always goes down, accuracy goes up, and like that's all we got. But problem with real data is like in endless config tweaks, changing parameters, what works, what not works. Again, reason behind them, analysis, insight, argument, domain expertise, and all those. So problem with even stock at a point, like for a decision, like what to choose. After that, we often like cannot reproduce what we have done, like 2 3 trial before that. So typically we do like we start research by reading papers, like draft idea from their literatures results, and then we add some kind of our intuition, innovation, and then draft of the entire methodology, and then we keep trying, tuning the each point of entire model or workflow, like from pre-processing, or we don't know what will work. So with a different pre-processing step, with a different different hidden layer, with a different number of hidden layer, we don't know what will work. So after drafting, like our methodology, we keep refining them, like changing code, changing parameter, changing data processing, and all. So this is like a fully research flow, a research literature review, then configs, then course and config, then experiment, then analysis the experiments results, like what we are logging, and analysis of their growth rate, their performance, and again after training their testing performance. And after analysis, we generate peer reports, and then decide what to choose next, what to tweak next, what to change next. And then after getting report, we update even like analysis code in configuration code, or even configuration parameter. And sometime we again and sometime we may change the entire methodology, like depending upon like next literatures we read. So this is the experimentation loop actually. So updating, tweaking hyperparameters, running and keep logging, like deeper logging at uh, at 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 any layers of the entire model, and then analysis, and then decide like what works, why works, and then what to do next. So the mess is like for example, we did hundreds of experiments. So imagine if you're keeping those in hundreds folders. So they may share codes, they may share configurations. So we need to copy paste few codes, copy paste another components in your entire workflow. And your folder names are like very 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 difficult to remember. And if, and again from the folder name you cannot get exact information about what is actually used there. So when you are trying to compare your experiments, like according to their performance, according to differences in their uh, architecture, code blocks, parameters, so it is different. It is actually difficult to traverse through different folders, to traverse through different configuration files, different log files. Even like you are, if you are keeping them in text file or CSV file, depends. So my contribution, like when I was in MSc first year, I faced the problem, and I started like small component of PyTorch Laplo, and then realized that this problem is exactly not solved by any other tools that are available. They are actually more focused on MLOps, production oriented, not for research oriented. So I started like building a PyTorch Laplo, and then adding few features. It actually becomes more generalized. Okay, so PyTorch Laplo is Python PyTorch based framework, where you can do experiments. You have to give each experiments a unique ID. You have to take care of that what name you have to give it to it. And yeah, and all the configuration, all the codes, artifacts will be saved in your local file system under that experiment ID. What you call here is pipeline ID, PPL actually in short. And then after it gets generalized, I named it PyLab flow, where user can design their own workflow. Doesn't matter it is from deep learning or any other computational research. And then I just like roughly started a open source community kind of, where researcher can say share their workflows, components, and experiments to with others, which will be open source, and obviously not sensitive ones. And we can make smoother, we can make smooth the entire research workflow, how people are doing previously. So PyTorch Laptop, I have told like previously, it actually manages all your experiments. Doesn't matter how much number of experimentation you are doing. All you can manage in fixed number of Jupyter notebooks. So because it actually manages all your configuration codes inside single folder, actually two folder. One is for one is for artifacts, one is for code. And code you can manage by yourself, and artifact it will actually take care of. And another thing, you can control everything, what artifact, where, how it will be saved. But one thing is very common is, you just have to use a single function. You can get experiments that differ by few thing or a number of things, depending on you. So every experiment is actually a JSON file that actually have the configuration of your entire architecture, like model, dataset, optimizer, whatever it takes, and all the parameters in a nested dictionary. And another thing, we are actually making the code blocks a dictionary, so that one code block can be used in different experiments, without copy pasting. You can just use their dictionary representation, and then fuse to your experimentation workflow, which is again a nested dictionary. And that thing will be saved in config.json, actually ppl_id.json, inside your local file system. And whenever you can reproduce just by using the JSON file. So this is the like typical workflow of using PyTorch Lapflow, in a fixed number of Jupyter notebook. Firstly, it will create the folders. It actually automatically creates what folder, how it will take care of, and then you have to design components, and then you have to configure experiment and then run it. And while running, you can log according to your code how you are logging, and then analysis, and then performance analysis, and then decide what to tweak, what to change next. And then this process is like in a loop. Doesn't matter how much number of experiments you are doing, like obviously all should be different. And again if you have more computation, more system, you can transfer easily the experimentation experiment configuration JSON file and few other artifact file or folders to different system just by using a function. Then you can do parallelly training different models in different model or different approaches in different system. And after that you can import them to your base system, and there you can analyze like what changes makes it better. So this is a static flow that will make you understand more. So it actually using 5 number of Jupyter file. If you are not using transfer, then it will be only 4 Jupyter file. One is for design component like debugging your component, what you have designed, and then you have to save it in your component folder. And after saving that, you just have to use their dictionary representations, and then configure your entire experimentation, and then it actually creates a JSON file of that configuration with a unique name. That name should be given by you only. And with the name, this is actually PPL ID. With the name, you can access your entire pipeline in another Jupyter file, and then train. Again, you can use Jupyter or even your Python file in CMD. And again, like while training, we generally log history, training and validation matrices. And after analysis, you can do test, and according to that you can decide what to change and what not to change. So this is a basic example. Actually, it is available on yes, this is available on GitHub. So one Jupyter file you need is to set up the project. It actually creates folders and files to manage all those things, all your experiments. And and then and then you need to make like 2 3 different Jupyter files to for different purpose, like one for training, one for analysis, one for debugging, or like designing your next component, if you are making. And then you can iterate over there. So here you can say like this project have mm, three actually is three different models, 3 different models, 2 different optimizer function, and they all like configured with an experiment ID. And actually we have pipeline class. This is actually backbone of the entire library, that actually takes the configuration and a unique ID, and saves it inside the configs folder that actually created by the library itself when you set up your project. So once your config JSON file is created, you can access the same configuration anywhere, just by the pipeline class, by giving it the same experiment ID. And after that, you can comparatively plot like live experimentation that is currently like running in other file or anywhere. So again depends on your logging strategy, how you are logging. If you're logging per epoch, per iteration, it can actually plot them while your model is running. So yes. So there is actually a function which actually gives you the description of all experiments and how they differ in just with that simple function, because we are organizing everything inside a folder. You don't have to look into the folder how it is doing. You just have to use the functions methods. So so here I would used only single function. Then this actually gives the data frame of information about your configuration. Like this is not deep as well. Again, we have a searching strategy that actually search for experiments that have components like component nesting to differ than this uh, first level. If, for example, your model resonate 50 underscore 40 needs another component which is again saved in your maybe in different location. So you can traverse to that. It actually filters all the experimentation, or all the experimentation that actually share the same components till the last one. So again, we can do parameter comparison, and side of that you can do their history comparison, and you can do other analysis as well. So okay. So after generalizing it, I just initiated just drafted a open source community kind of which is expertquick.org, that actually built on PyLab flow, and will provide different workflow for different kind of different area of research to smoothness your research workflow to easiness, and you can share your workflow and components with other researchers, uh, making it a collaborative research community. So I'll be I'll just show you a use cases of that. Yeah, that Stasi's go like okay, okay. Okay, so okay. So please everyone, like if you think it like important, you can share you can follow our LinkedIn page. GitHub organization is there as well. So you can simply follow us there. Thank you.